there is something called a confusion matrix. So whenever we are doing a classification algorithm, the best way to figure out how well your algorithm is performing is by looking at the confusion matrix. Now, this topic or the content that I'm going to cover in the next half an hour, 45 minutes, if you are doing an interview, and if your interview is with somebody who is a data scientist, you can expect 3 or 4 questions straight out of this next 45 minutes. They definitely want to make sure that you understand what you are talking about. Again, I'm saying that data scientist, sometimes if your interview is with a software engineer, it might be a little bit different, but a data scientist would definitely focus and ask you some questions about this. So confusion matrix is the best way to actually look at how your model is performing when you are doing classification. In a confusion matrix, what you have is that in rows, so this row here, you have actuals. So actuals are in row, the top row is actual no, and the bottom row is actual yes. In columns, you have predictions. And the first column is prediction no, and the second column is prediction yes. So a confusion matrix is set up like this, that in rows, it has actual values or true values. In columns, it has predictions. That's how a confusion matrix is generally set up. It could be the other way around also, but generally it is set up like this. And in sklearn, it is set up like this. In confusion matrix, what you do is you find out what the intersections are. So you basically see where the actual is a no and a prediction is a no. So you can see here that the actual no and prediction no are common 50 times. So your algorithm was 50 times it was correct in actually predicting no. The actual no's in your data set are 50 plus 10. So your algorithm was wrong or was too enthusiastic and it predicted 10 of the no's as yes. When it predicted 10 of the no's as yes, it also predicted 5 no's which were actually yes. And then it has this where the actual is yes and the predicted is yes. You were correct 100 times. So this is how a confusion matrix is laid out. Any questions on that? Does this make sense? Because this is the kind of the foundation of how confusion matrices work. And let me know if you have any confusion on this. And I can't hear you. Maybe it's my side, but
Hello?
yes, I can hear you now. Yes.
Okay. So I have a question. Um,
Yeah.
how can you get the confusion matrix to flip true and false? So for example, right now it's so no is the top left
Mhm.
and yes is the bottom right. Is that usually how people present it? Is it possible to flip it so yes is the upper left and no is the bottom right?
So my understanding is that in sklearn, it is not built in. Can you do it yourself? Yeah, you can build your own and you can do it. You can write a function that actually checks for yes and then puts it in the top box and checks for no and puts it in the bottom box. But for sklearn, or at least not that I know of, that it can be done or it can be flipped. Now, sklearn actually displays the results like this. So this is sklearn. Now, if you go and some other softwares actually have them flipped, as you were saying, that um, the predicted are in rows and the actuals are in the columns, or they have the yes on the left hand side and the no on the right hand side in predictions. So I've seen those flipped around, but sklearn, I don't know that if they flip this around. But if they don't even flip this around, you can actually manually flip them around if you want to.
Okay, so like because the targets are going to be zeros and ones, so sklearn will always put zeros in the upper left and then ones in the lower right. So technically, if you want to flip it, you could just change the true and false to 1 and 0 instead of 0 and 1. Right.
Yeah, you can actually reverse your target. Yes, you can do that.
Okay.
But I would suggest that instead of doing that, you actually
Hmm.
just flip your confusion matrix around.
Okay.
Instead of actually making that, okay, if the person did not pay the loan back, you make that one. Instead of doing that, you actually just flip the confusion matrix around.
Okay.
Actually, I had a student who was he actually was interviewing for a job. They actually gave him this task to actually build a confusion matrix.
Oh, okay.
So build a confusion matrix, and I don't remember that what orientation, but they said that you cannot use sklearn confusion matrix. You have to build
Mm,
your own, and he had to build that. So that
interesting.
yeah, so that was actually given to one of our students at Learning Fuse.
Okay, cool. Okay, thank you.
Yeah, no problem. Okay, so this is how the confusion matrix looks like, at least for sklearn. Now, these no columns where they match, these are called true negatives, TN, true negatives. Where you have both yeses meet, that they are called true positives. So true negatives, true positives. A false positive is where your algorithm predicted yes and the actual was a no. And a false negative is where your algorithm predicted no, but the actual was a yes. So this is the basic terminology. True negatives, true positives, false negatives. Does that make sense? And any questions on that? No. Okay. So once you have these true positives, true negatives, false positives, and false negatives, there is a concept called type 1 error. Type 1 error is basically false positives. And false positive is that when you are telling somebody something that they are not. So in this case, the doctor is saying to this man that you are pregnant, where the guy is clearly not pregnant. So when you have these false positives, these are your type 1 errors. A type 2 error is that when it's a false negative. And a false negative is these ones. So this top right corner is type 1 error. This is type 2 error. A very, very common question in an interview. What's a type 1 error? What's a type 2 error? Very common question. And a lot of times people focus more on false positive versus false negatives. They don't remember what is type 1. And if you ask me 2 days from now, I would also don't remember which one is type 1, which one is type 2. So please review it, because this generally is a very common question. Okay, what's a type 2 error? And type 2 error is false negatives. So that's false negatives and false positives and type 1 error and type 2 error. So this is out of the way. Make sure you understand these. Then accuracy, when we measure accuracy, what we do is we add the true positives, so the right bottom corner, and the true negatives, top left corner. We add these two together and we divide it by the sum, by all of it. So we will add this 50 and 100. So 50 and 100 will make 150. And then we will add all of them together. So 100 plus 50, 150, 160, 165. So we divided by 165. That is that is accuracy. This is how accuracy is measured. Now, the problem with accuracy is that if one of your classes is a majority class, so for example, if you have a lot more true negatives, if you have a lot of true negatives and very few true positives, accuracy does not work because this majority class actually dominates your result. So as soon as you have class imbalance, accuracy goes out of the way. It is not a good metric to actually calculate anything if your data is imbalanced. Then comes the three measures that are very commonly used in data science and very common questions: precision, recall, and F1 score or F score. In precision, we take the true positives and we divide them by true positives plus false positives. So you can see the precision is this blue kind of circle here. So you take the true positives, which is 100, and divide it by the sum of true positives and false positive, which is 110. That is precision. And recall is when you take your true positives and divide it by true positives and divide by the sum of the true positives and false negatives. This is a recall. So precision and recall, and generally they will ask you, what is precision, what is recall? Can you actually talk about that? So memorize these formulas and you should be able to talk about those. So can you see something kind of unique between precision and recall, which is kind of different from accuracy? Giving you guys 5 more seconds to think about it.
Seems to focus mostly on the positive values.
Oh, beautiful. The difference between accuracy and precision and recall is precision and recall actually just focuses on the positive class. Precision is positive in predictions. Recall is positive in yeses. That is the answer. Great answer, Duncan. That is the answer. Precision and recall both focus on the positive class, generally the minority class. Now, who wants to explain to me in English what is precision? You can try
I can give it a
different
shot.
language also. I may not be able to understand that, but we can try any other language also. Go ahead, Duncan.
Then I just lost my train of thought when you mentioned the other languages. Give me a moment. You're
That
tripping
was
me up, Zia.
that was why I asked you that.
Oh man.
No, I'm joking. Yeah, think about it. Let's try to explain precision.
How many times when it is a positive value, it's actually correct? What percentage of that?
Very good. Very good. So precision actually measures when your algorithm predicted a positive, how many times it is correct in predicting that. So precision explained in simple English is how many times your algorithm is correct in its prediction of positive class. All right, now let's try recall. All right. Who wants to take a crack at recall?
Sure, I'll try.
Sure. Yeah.
Recall measures when out of all of the actual yeses, how many the percentage of the time that your algorithm finds them. How yeah, the the percentage of the time that your algorithm finds the actual yeses.
Excellent. So very good. So recall is basically how many times did your algorithm predict correctly the actual yeses? Does that make sense? So prediction is, precision is how many times was your algorithm correct when it predicted the positive class? Recall is how many times was your algorithm able to predict correctly the positive class in true values? And generally speaking, these are the two metrics that you generally should measure when you are doing classification, because that's kind of the right metric. F1 score is a harmonic mean, or F score is a harmonic mean of precision and recall. Sometimes people use it. For me, I personally prefer precision and recall individually. Can somebody talk about why would precision and recall individually might be a little bit better than the harmonic mean of precision and recall?
Sometimes you care more about one or the other.
Excellent. In some situations, a recall might be way more important than precision, or in other cases, precision could be more important than recall. Can anybody give me an example of where recall is more important?
If you're trying to get something to tell the different bird species.
I think we might have to debate about that, but let's go with a different example. Healthcare, cancer detection. Prime, companies want 100% recall because they do not want to miss any patient that has a chance of chance of cancer. They do not want to miss it. So they want 100% recall. They do not care as much about precision. And generally, there is a little bit of a tension between precision and recall. As soon as you try to increase your recall to 100%, your precision starts to slip. So generally, there is a tension between the two. And the healthcare example was that, for example, if you miss a patient and you do not screen them for cancer, and they actually have cancer, what is the cost of it? The person can die. Very expensive cost. That's why companies want 100% recall. Now, when they go for 100% recall, as I said, precision could go back, could go down. So when it goes down, what will happen? What's the worst that will happen? Somebody would get a call for an extra screening. They might have a lousy evening and a bad morning next day, and they get tested again, and they are fine. So what's the worst that can happen if you have a bad precision? The person might have to do the test twice, or they might have a bad evening or a bad night or a bad day. But on the other hand, for recall, the cost was very, very high. So what I'm trying to kind of showcase here is that the cost for recall is different from cost for precision. And that's why measuring them individually is a better idea. An example for where precision could be more important is the loan case that we were doing. You don't want to not give loan to everybody. You basically want to make sure that, okay, if you don't give out loan to 100 people, the 90 of them actually do not pay you back, because you don't want to stop your business. So you don't want to hurt your business by actually not giving out loan to anybody. So at that point, precision might be a little bit more. You want to focus a little bit more on precision. Or for example, if you are trying to predict that if you are managing a very big data center, like for example, a very large organization like Best Buy or somebody, and they have like many thousand computers, and you're managing those many thousand computers, and you have an algorithm that actually tells you that which computer can actually fail because of a hard drive failure. Now you want your precision to be very, very good, because you don't want to be changing hard drives on every computer so that nothing fails, because then you'll be basically almost slowing down your business. So those are cases where precision might be a little bit more important than recall. But as I said, that like for example, healthcare is a prime time use case for recall. Recall is because the cost of missing a diagnosis is very high. Does that make sense? And is any questions on that?
You think of it as like precision is like the accuracy of the yeses,
You can think
and
of that,
then
yes.
recall is like find, like finder. It's like how often can you find the ones? How often can you find the yeses?
Yeah, you can think about that. It makes it clearer. I actually also use and the reason I kind of stay with this type of this type of confusion matrix is because in my head I have that precision actually is vertical and recall is horizontal. And I just always keep it this way so that it actually kind of fits in my brain that, okay, I'm going to focus on precision versus recall. But yeah, it's basically whatever makes it easier for you to kind of remember these. And try to memorize these. These are two formulas, so try to memorize them. That helps, because sometimes in an interview they might ask you what's the formula for precision versus recall.
So
All right. Yeah, go ahead.
whenever so like my house has all these rocks,
Mhm.
and my Tesla, like whenever I park in my driveway, there's always like a bunch of people that show up on my camera on my Tesla, because
Uh-huh.
it shows it shows people,
Mhm.
like it tries to identify people, but it identifies the rocks as people. So
Oh,
it's
yeah.
like it doesn't want to misdiagnose a person. So it's
Yes.
like it's safe and predicts rocks as
Yeah,
people.
so it is actually focusing more on recall, doesn't want to miss any.
Yeah.
Yeah, it actually predicts that. Yeah. Again, it truly depends on the cost. All right. Any questions on this? Again, very important. Generally, they will ask you questions about this.